We have one more algorithm from the textbook to go over. It's the algorithm that you're actually going to be writing code for in the assignment. And then we'll just talk a little bit about implementing stacks, which is pretty fun, actually. They turned out to be pretty elegant when it comes to implementation. And then we'll be done talking about stacks. So any other questions or comments before we dive in? All right, so I guess I should get the textbook going and get a Word doc going. One of these times I'm going to try using the whiteboard instead of a Word doc. I wonder what that's like.
It's about the same.
Share. Oh, if I use the whiteboard, I can't use the whiteboard and also something else. I guess that's a good reason not to use it. All right, everyone seeing the textbook and the Word doc now? I see a nodding head. That's good. All right. Thumbs up. All right, let's see where that pseudocode is. Pseudocode algorithm that converts an infix expression to postfix form. That is what we want.
It's a little bit small from my perspective.
Okay. Let's make that a little bigger.
Thank you. That's awesome.
Okay, so the expression that we're going to work with is going to be A minus, oops, B plus C times D by E. Okay, and we're just going to need a CH. We're going to need a picture of what the stack looks like. And we're going to need a picture of what the expression is so far. Sorry, I'm just trying to manage my real estate here. Okay, so we enter the for loop. First time through the for loop, the character is A. The stack is, trying to think if we want to do the stack. I guess we want to do this, what the stack looks like at the end of the loop iteration. So in the case of A, what we do is, that's an operand. So what we do is we append that operand onto the end of the postfix expression. That dot right there is representing concatenation or appending a character to a string. So the stack is still just going to be empty and the expression is just going to have A on it. Everyone okay so far? Okay, so second time through the loop. The character is the minus symbol. So what we do is we come down to the operator case. It's the most complicated one. We got a while loop. While the stack is not empty and something else, and something else. So it's a bunch of ands, and the first and is already false, right? Because the stack is empty. So we don't execute the while loop. We don't enter the while loop. So next statement after the while loop is push the character onto the stack. So now the stack is going to have minus on it, and the expression is still just A. Okay, next time through the for loop, the character is open paren. Case open paren. Every time we see an open paren, all we do is we just push it on the stack. So now we're going to have minus and open paren on the stack. Expression has not changed. All right, next character is B. That's an operand, so we just append it to the end of the expression. So stack doesn't change. Expression is now A, B. All right, after the B, the next character is plus. That is an operator. So we come to the while loop. The stack is not empty. A stack.peak is not an open paren. Oh, that's false. A stack.peak is an open paren, right? You guys will stop me if you have a question, right? Or type in the chat or something. So again, the while loop condition is false. Fails on the second one here. So we don't enter the while loop. We just push the character onto the stack. So now the stack is going to be minus open paren plus. Expression has not changed. Okay, next character after the plus is a C. As always, with an operand, all we do is we just append it to the end of the expression. Stack doesn't change. After the C, the next character is a star. So that puts us in the operator case. While the stack is not empty, that part's true. A stack.peak is not an open paren. That part's true. The precedence of the character, which is, I didn't type it yet, huh? Star. The precedence of the character is lower than the precedence of whatever's on the top of the stack. True or false? The precedence of multiplication is lower than the precedence of plus.
False.
Someone has to say something now. False, right? Because the precedence of multiplication is higher than the precedence of plus. Good, so still not entering the while loop yet. So we're going to just push that character onto the stack. So the stack becomes minus open paren plus times. The expression doesn't change. Next character is a D. I'm kind of getting the hang of this now. Every time I see an operand, all I do is I just put it at the end of the expression. So minus open paren plus star. A, B, C, D. Okay. Next character is a closed paren. So now we're going to be down here at the closed paren case. While loop says while a stack.peak is not an open paren. So that kind of makes a little bit of sense. I mean, I realize that we've been sort of blindly working through this algorithm, and I don't know about you, but for me, sometimes that's kind of the first step in understanding an algorithm is just run through it a few times. But I'm just kind of thinking a little bit here and going, that kind of makes sense, right? When I see a closed paren, it makes sense that I'm probably going to process everything back to where I saw the open paren, right? So while a stack.peak is not an open paren, I'm going to pop the stack and put that character at the end of the expression. So first time through that loop, the star is going to go over to the expression. Oops. Second time through that while loop, the plus is going to go over. Oops. The plus is going to go over to the expression. All right, this is making me crazy. Hold on. There we go. A, B, C, D times plus. And so after the second time through the while loop, we go back to the top and we say a stack dot peak is an open paren. So this condition is now false. So we exit the while loop and we pop that open paren off the stack. So now the stack is going to look like just minus, and the expression is still ABCD star plus. Yeah, the problem with that is then I can't control the font size. I think I probably just need to get better at getting my Apple Z1 word format something for me. Okay, so now we're back at the top of the loop. The next character is the division symbol. So that's an operator. So we're at this while loop while the stack is not empty. So that's true, it's not empty. While a stack.peak is not an open paren, that's true, it's not an open paren. And the precedence of the character, division, is lower than the precedence of what's on the stack, which is minus. So again, this is false. This has not been true for us the whole time, huh? This is false, so we do not enter the while loop. So we push character onto the end of the stack, and the expression doesn't change. Okay, back to the top of the loop. The next character is an E, so I just append it to the end of the expression, and the stack doesn't change. And up at the top of the loop, now I'm done with this loop, right? The loop was a for each character in the infix expression. We have made it all the way through the infix expression now. So we're exiting this loop. We come down here to the end. While the stack is not empty, move everything over onto the end of the expression. So first time through that loop, we're going to pop the division off the stack and put it on the expression. And then the second time through that loop, we're going to pop the minus operator off the stack and move it over onto the expression. Okay, so there we have it. That is the correct expression for that is the correct postfix expression for this infix expression. If we want to play around with this a little bit just to convince ourselves that that's really right, I guess what I would do is I would, maybe just for my own purposes, I would say, okay, there's an expression and that's the innermost expression. That kind of matches this, right? Because the first thing you would do in this expression is the C times D. And then next would come the B, oops, which also matches this, right? Because after the C times D, the next thing you're going to do is the plus B. And then, let's see, the next, can you tell what the next square brackets are I'm going to put in here to indicate the next operator? I've got an operand A. I've got this whole mess in the square brackets, which would be another operand, so a second operand. And then I've got this operand E. So the next expression, where an expression, when I say the next expression, I mean where can you find operand, operand, operator, right? That's going to be here. Operand, and then the second operand E, and then the operator division. And then that makes sense because this whole mess divided by E comes next in the infix expression. And then after that, I've got operand A, operand all the rest of this stuff, and then the minus, which means A minus all the rest of this stuff, which is what I had up here. No, I don't believe this handles unary minus. I think it only handles binary operators. I mean, yeah. All right, any questions about that? I realized that I didn't really attempt to like explain why this algorithm works. I hope that you'll have a chance to take a look at it. You'll definitely have plenty of time to work with it since you're going to be writing, translating it into C++. He also talks about it in quite a bit of detail up here. The following is a high-level description of what you must do when you encounter each character as you read the infix string from left to right. So, you know, this is sort of his attempt to sort of explain what's going on in that algorithm. Okay, so take a look at that to make sure you kind of understand what's going on, at least at a basic level. And in the assignment, you have to do a couple of these traces, I think. And then you also get to translate this into C++. All right. Any questions about that algorithm before we move on? And the next thing we're going to do is talk about stack implementations. Yeah, I agree. For me, one of the best ways to understand an algorithm is to just trace it through a few times and watch what happens. Okay, so let me pull up a program that uses a stack. And what my philosophy here for lecture is going to be is I'm going to just try to do the absolute simplest stack implementation that I can imagine. When we look at the textbook and when you go to do your assignment, we're going to be doing stuff with, you know, it's going to be a templated class, and we're going to be deriving it from an interface and all that kind of stuff. What I want to do in lecture is just strip out all that stuff and just go super, super simple stack with whose elements are of type int and go from there. So here's a little client program that is going to use the stack implementation that we write. Hopefully that's big enough. I don't think there's any way for me to make that bigger, or at least I haven't figured it out yet if there is. So you can see I've got two different include lines here for the stacks because I'm going to do an array implementation of a stack. And I'm also going to do a linked list implementation of a stack. And I just uncomment whichever one is the one I want to use. So I just have a little program here that says enter a string of parens, and then if the string is balanced, I print balanced. If it's not, then I print not balanced, and then I go around again, okay? And then here's the actual function that checks to see whether the parens are balanced or not. We basically did this in the textbook on Tuesday. Same thing. The only reason we're doing this here is so that we have a way to test our stack on the implementations that we're about to write, right? So declare a stack, go through the string for each character. If it's an open paren, I push it on the stack. If it's a closed paren, well, if the stack is empty, return false because my stack wasn't balanced. If the stack is not empty, then pop the top element on the stack. Keep going through the string until I get to the end of the string. If I get to the end of the string, then I return true if the string is empty. I'm sorry, if the stack is empty. I return false if the stack is not empty, because if the stack is not empty, that means I had too many open parens. Okay, not that part's not really what we're studying today. Just had some code up there, so I had to go through it. The point here is just to have something that we can use to test our code on. Okay, I think I have a header file here. Here's my header file for an array implementation of a stack. Just have 5 functions: constructor, push, pop, empty, top. That's it. The data we have is we've got an array, limiting the size of the stack to 100. See, I'm keeping it so simple that I'm not even using a constant there. And then we need to know how many items are on the stack. Okay? Any questions about this? So the way this is going to work, I don't think it'll be necessary for me to draw a picture of this, but please tell me if you'd like me to just stop and draw a picture. But basically, we're going to put our elements in an array. The top of the stack is going to move towards the right as we put the things in the array, right? So the first thing we put in the array is going to be at a sub 0. And then if we push something onto the stack, that's going to go at a sub 1. So the bottom of the stack is always going to be at a sub 0. That makes sense to everybody? Anybody want me to draw a picture? That was 2
I'm good.
opposite
That makes
questions.
sense.
So at this point, it's not fair to just say yes or no. No one says anything, I'll assume everyone's good. Okay, so here's a question. Yeah, I love drawings. I just don't have I have to use, I don't know. Actually, I don't even know what I would use. Can I use the whiteboard? All right, you guys, now you asked for it. I'm gonna just stop for a second, play with the whiteboard. Never used it before, so be patient. Can I just draw? I actually have a pen thing here. Maybe I'll try that. Give me a second. Nope, doesn't look good. Yeah, I'll have to play with that sometime in class. Yes, I'm trying to do this with a touchpad. I don't have a mouse, but let me try, okay? Let me try. So we can laugh. We all have a good laugh, okay? I can make a box, right? And I can draw lines in the box. They don't even have to be straight, right? And it's just like free draw. Let me just try this. Yeah, that's not gonna work. I want to just make some dots here. Dot, 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 and then a line at the end. Okay, and then we need some indices. So I'm going to say 0. Whoop, that didn't work. 0, 1, 2, And then this would be 99, right? Because the size of the array was 100. Okay. And then we also have this other variable here named num items. So text. This variable is called array. And this variable here is called num items. All right. Select. There we go. Let's get rid of this. Ah. Okay. When we first start, we're going to have num items is going to be what? Help me out here. We first start, we've got an empty stack. What's num items going to be?
0.
I know this is a tough one. Someone be brave.
I think somebody answered 0.
All right,
0.
I'll tell you. Num items are going to be 0 when we start.
I don't think you can hear us.
Right? Next question.
Can
Get ready.
you hear us?
Oh,
Mic test,
am I
1,
not
2.
hearing you? Are you guys talking and I can't hear you?
Yeah, we've been talking the whole time.
Yes.
My volume was turned all the way down. Okay. I can hear you now. No wonder no one was saying anything. Jeez. Okay. All right. What's in the array? I thought it was odd that everyone just decided to use the chat today. So when we first start, we set num items to 0. And then what's in the array doesn't matter, right? Because it's just garbage, junk, and we're not going to be looking at it, right? Uninitialized, and that's fine. So let's say I push the number 7 onto the stack. What's going to happen? The 7 is going to go in array sub 0. And what's going to happen to num items?
Increment.
Increment num
Minus.
items.
Incrementitis.
Okay. Let's say I want to push 13 onto the stack. So when I push onto the stack, it's going to go at array sub num items, right? And increment num items. Oops, close enough. Okay, let's do one more. Let's push 19 onto the stack. So the 19 goes array sub num items, and num items becomes 3. All right, I need to take a quick break, you guys. Got a quick phone call.
No worries. Bathroom break?
Okay. You leave up your client.
Anyone doing?
All right, wasn't what I thought it was. Okay. All right, so we just did 3 pushes. Let's talk now about pop. Okay, let's say if I want to pop the stack, what's the code going to look like? It's going to be return array sub what?
Num
Two?
items.
Oh, yeah.
Num items? Is
Yeah.
that right?
0, 1, 2,
What's at the top of the stack right now?
19.
19. If I say returns arrays of num items, is that going to give me the 19?
No, 2. Yeah, sub 2.
Right. So how's that? How's that? It's not going to always be array sub 2, right? So how am I going to say that in the code?
Yeah, num items minus 1.
Script num items minus 1. Yeah, there you go.
Yep, num items minus 1, exactly. Good. So I just realized that I'm actually sharing my whole screen still, right? So you can see the code?
No.
Oh, you can only see the whiteboard. Yeah, okay. Yeah, okay. Which is what I had predicted before. All of a sudden I was like, hey, wait a minute. Okay, and then let's say, so we've talked about the code for top, and I'm not doing the code as we talk about it because I want to get all of the talking done first so I don't keep switching back and forth. But let's just talk about pop. What's pop going to look like? Oh, Patricia, you will have to tell me more about split screen. I don't know what that is about at a later time.
Okay.
So when I want to pop the stack, what do I do?
Take out the item that was most recently added.
Take out the item that was most recently added. That is correct. So I want to take out the 19. What's that code going to look like? I mean, take out is probably not quite the right way to say it, right? It's not like I'm going to actually remove the 19 from that memory location so that there's now nothing there.
Would a better way to say be reassigning the value somewhere else, essentially?
No, that's not going to really help either.
Mm.
So if I pop the stack, how many items am I going to have left on the stack?
2.
2. And which means what?
Num items is going to decrease.
I got to decrement num items, right? So if I decrement num items because I'm popping an item off the stack, it makes sense I should decrement it, right? Okay, so what else do I have to do to make sure that the stack is popped correctly? And I'll give you a hint, that's a trick question.
Well, you could make sure that the size isn't less than 0.
Yeah, I could do that. So for both top and pop, I'm probably going to want some sort of a protection in case the user calls that function when the stack is empty. That is true. But so in this particular case, I decremented num items to 2. What else do I need to do?
Remove the element from the array.
The answer to my question is nothing. I'm done. Right? Doesn't matter what's here because I'm saying the number of items is 2. So that means the 7 is the bottom of the stack. The 13 is the top of the stack. Nothing else matters, right? Does that make sense? So I can ask that another way.
Is that not a memory leak?
No, there's no memory leak here. In fact, we're not even using dynamic memory, right? This is all on the stack.
Yeah.
So just look at this picture and keep in mind that, you know, there's garbage down here, right? We don't know what's down here. Could be a 25. It could be negative 4,962 or whatever, right? There's stuff down here, always was. Okay, so take a look at this picture. That is a picture of the computer's memory. What is the stack that picture represents? I'll answer my own question unless someone really wants to. That picture represents the stack, 7 on the bottom, 13 at the top, and that's it. Everyone okay with that?
So nothing happens to the values.
Correct.
We're just specifying the bounds of the stack.
Correct.
Yeah. Okay.
The only time you change a value is when you push something, right?
Correct, yeah. Yep. And that makes sense. That's the only time you're actually adding any information to the stack, right? Okay, so just for fun, I kind of feel like we should do this a couple more times. I don't know, am I wrong about that? What happens if we now, let's say we push the number 17? Well, first I put the 17 at array sub num items. Then I increment num items. Right? So there's a picture of the computer's memory. What stack does that represent? It represents the stack, 7 on the bottom, 13 on top of the 7, 17 at the top of the stack. That's it, right? So I could draw a separate picture over here to say, okay, this is the low level picture of how we are implementing the stack. What's the high level picture of the actual stack that we're representing? I don't think I will take the time to do that, but I think you get the idea, right? Let's say now I push the number negative 19 onto the stack. First step, array sub num items gets negative 19. Oh. That's not working. All right, give me time out for a second here. I think I can fix this. Ooh. All right. So array sub num items gets negative, what did I say, 19? Okay. And increment num items. Okay, so someone tell me what stack that represents now. What's the stack? This is the picture of the low-level computer memory. That's an array and an int that we are using to represent the more abstract concept of a stack. What does that stack look like? What's at the bottom of the stack? Oh, there we go. Thank you.
Hey, nice.
Yes, that is correct. Everyone okay with that?
Yeah, quick question. So my apologies to the rest of the class. I'm just getting sort of caught up. Is there any difference between a stack and an array with just specific bounds? Like, is it stored differently in the computer at all, or do you know what I mean?
The way that a stack is stored in the computer is what I'm showing you right here.
Oh, I see.
Right?
So would it be safe to say it's just an array with specific bounds?
It's an array with, well, it's an array that has a function named push defined on it, and a function named pop defined on it, and a function named empty defined on it.
Got it. Okay. Okay.
Although,
thank you.
We maybe I should move on a little bit here. That's not necessarily true. We could implement the stack some completely different way. right? All we know about a stack is that it has a top and a bottom, and you can push things on it and you can pop things off of it, right? Yeah,
Gotcha.
that's true for a stack. All the stacks we're going to be dealing with in our programming, we're going to be dealing with them in the true abstract sense. Okay, look at the stack class. There's no way for a client programmer that is using this stack class to access anything but the top of the stack, right? I'm not sure if I totally agree that there can't be a limit to its size. I think you could have a stack in the true abstract sense that has a limited capacity, but we won't go down there. Okay, let's just go over to the code for this now. So here's my implementation file. I need a site include. I don't need that. I guess I'm just going to use assert to keep things simple. Okay, what do we need the constructor to do?
You're still sharing the.
Oh, thank you.
Or...
Let me share. Too bad it won't let me share the whiteboard just as part of the desktop. Okay, so there's the code that I was just typing. What does the constructor need to do? Thinking back to that picture, what does an empty stack look like in terms of the data members here? Go ahead, Patricia.
Initialize num items to 0.
Yeah, and that's it. We don't have to, it doesn't matter what's in the array. Num items is 0, we're good. That's an empty stack. Okay, done with the constructor. I guess I'm doing an array of chars, not ints. Okay, so we'll think back to when we were looking at the picture. I think I said this several times, so I'm just going to go ahead and type it. What we said is array sub num items gets the new value, and then num items.
Wasn't it num items? Wasn't it num items -1?
That would be pop. No, okay. It wasn't. It was. Yeah. It was in the top function. It was num items -1. Any questions about push? You want to see the picture again to be reminded how that worked, or? I'm gonna go with that. If you need to have another look at that, watch the recording. Okay, let's look at pop. Okay, so we talked about the fact that pop doesn't work if the stack is empty. So I'm just going to use assert for that. Assert basically just halts the program immediately if its argument is not true. So we're going to assert that the stack isn't empty. And then the way we did pop was just num items minus minus, and that was it. Okay. I realize this probably would have been more ideal if I could have put these next to each other, because I'm afraid that now that I'm typing this code, you don't remember about the num items minus minus that we did like 10 times. But if that's the case, please go back and take another look at the recording. Then we've got jar my stack : top. Going to do the same thing with assert. And we return array sub num items minus 1. Okay, and then there's one other function, empty, which is just return num items get 0. Top is the peak function in the text. Yes, that is correct. Let's call this my stack array.cpp. Okay. Any questions about any of this? Just a quick side point here. In the textbook, he does this a little bit differently. So for the data type, instead of having a data type called num items, he has, did I say data type? Instead of having a data member named num items, he has a data member named top, which stores the index of the top item in the stack, which is fine. It makes it so that everything is off by 1 from what we're doing, right? Because if you remember from the picture, the top of the stack was always, the index of the top of the stack was always num items minus 1, right? So when you read through the textbook and you look at the examples in there, you're gonna, like, you know, here, instead of num items minus 1, you're just gonna see top. Here, instead of num items, I believe you're gonna see top plus 1, something like that. So just a heads up, so you're not totally befuddled when you see that it looks a little different in the textbook. I actually took his files that he did for the textbook examples, and I changed them over to this system, which I just personally like better. And so you guys are stuck with my my way of doing things when you do your assignment. Okay. I think I am completely done talking about array implementation of a stack. Any questions? All right. I want to talk a little bit. I mean, I get the feeling that there's still a little bit of unclarity about the distinction here between the abstract thing that we are implementing, so the stack, and the fact that we have to actually use low-level stuff like arrays to implement it. So now that I've brought that up, I can't think of any other way to say it that hasn't already been said, but just something that is really important to try to keep straight, right? And so part of what we're doing here is we're going to now switch gears and we're going to implement a stack in a completely different way, but we're going to have the same client programmer is still going to work, right? So here's the client program. Yeah, I agree, Kaylin, 100%. So if that sentence I just said is still a little fuzzy, that's definitely the thing you're going to want to work on. So let's see, I need to get to my correct folder. And so I'm going to say compile stack client.cpp with my stack array.h, and we'll see how many errors I made. I don't have stack client. Oh, it's not in the right folder yet. Same probably with my .h file, I'm guessing. Yeah. Try that again. All right, what didn't we like? Whoa. Oh, try that again. My stack.h not found because it's my stack array.h. Sorry. My stack. Oh, my client, you know, my implementation, my stack. Okay. All right. Any bets on whether it's going to work this time? Nope. Looks like I had a stray character there. My stack array.cpp line 32. Oh yeah, typed the T by accident. All right, bets this time. All right, looks good. And enter a string of parens, open, 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 close, close, open, close, close. I think those are balanced. 1, 2, 3, 2, 1, 2, 1, 0. Okay. So there we have it. We have a client program that declares a variable of type myStack and uses it to check to see whether a string of parens is balanced or unbalanced. Okay, so next thing we're going to do is I'm going to show you that we can, this exact code with no changes will work when I implement the stack in a completely different way. Okay. I'm thinking I might cheat a little bit here and just throw the code up and look at it. I hope that turns out to be okay, but it does. Okay, let's take a look here. I combined the implementation file and the header file into one just to keep things simple here. Don't ask me why I did it on this one and not on the array one. So here's my header file. The public part is exactly the same, except now I'm going to have a destructor apparently. And then the private part is a, it looks like a linked list, right? So I'm going to have a node struct with a data part and a next part. And then I'm going to have list, which is going to be the pointer to the first element of the linked list. Okay. This also turns out to be very cool. Like a stack in some ways is set up perfectly to be implemented with a linked list, because like a stack, a linked list is most easily accessed just from one end, right? So if you can imagine a linked list, we're just going to be, when we push something onto the linked list, here, hold on. So here's my variable in my stack object called list. Okay, and it's on the stack. And what's going to happen is I'm going to have, like if I, so let's draw this same stack that Kaylin actually drew in the chat for us a while back. And let's see how it's going to look if we implement it as a linked list. Okay, and I'll do one at a time. So let's say we push 7 onto the stack. So make a node for it. Put a 7 in there. List is going to point at that node. And the next pointer coming out of this node is going to be null pointer. I guess I should just be good and draw the 2 parts of the node, the data part and the next part, right? And the next part is going to be null pointer. We draw a null pointer like this, a diagonal line going through the box. Okay, so what's that stack? That is a picture of a stack with just a 7 in it and nothing else, which is what I want because I was just illustrating what happens if I say push a 7. Okay. Now let's see what happens if I push 13 onto the stack. Can I copy that? Nah. I'm going to try. So I need to create a new node for the 13. And there's my node. And I'm going to put the 13 in the node. Okay, and then what else? What do I want to do with the pointers here to make this go at the top of the stack? I'll give you a hint. What we're going to do is we're just going to make this new node be the first node in the linked list, just like we did with the bag class and the set class when we added things to them. So that means I'm going to have to take this arrow, which it won't let me select. I think it'll let me just move it down here. I'm going to make this arrow point down to the 13. And we're going to make the 13 point to the 7.
In code, though, would it work the other way? Like you'd have to make the 13 node
correct.
pointer equal the head pointer and then repoint the head pointer to the 13 node?
Correct, yes.
Okay.
Yes, I did that backwards from how we'd have to do it in the code.
Okay, I just wanted to, for sure.
Good point. Okay. I wonder if I can expand this. Yep, okay. So now if I want to push the 17, I'm just going to draw another node for the 17. Remember, all this over here is on the heap, not the stack, right? So I'm going to push another node onto the stack. That means I am putting another node at the front of the linked list. So I have to put the 17 in there. is. And now I'm going to make the 17 point to the same thing list is pointing to. So keep that in mind. In our push function, when we go back and look at the code, there's going to be a statement that says, whatever this new node is, arrow next gets list, right? In other words, make the new node arrow next pointer point to the same thing that the list pointer is pointing at. And then we're going to have a statement that says make list point at the new node. Right? So now we've got a stack. The 17 is at the top, 13 is next, 7 is at the bottom of the stack, kind of upside down in my picture. Is that making sense? Does it make sense why linked list works really well for this? Because the idea behind a stack is that if I have a stack with a 7 at the bottom, it's going to be hard to get to that 7, right? And that's exactly the way it is with a linked list. With a linked list, the 7 is the last node in the linked list, and that makes it hard to get to, right? Okay, I'm going to switch over to the code. So I didn't actually, I'm not going to do a 4th node. So really, this is just the stack, 7 at the bottom, 13 on top of the 7, 17 on top of the 13. So the num items would be 3, right? Okay, back to the code. So, oh, you know, I forgot that I've done this weird thing. Let me just make this list gets null pointer. Okay, turns out I am going to be writing this from scratch after all. Okay, so pop. Okay, let's pop. Pop just means if you don't count the fact that I need to do memory management, pop just means nothing more than make list point, switch list. So instead of pointing at the first node in the linked list, it's pointing at the second node in the linked list. Does that make sense to everybody? Or does anybody request that I go show you that in the picture? Ignore the rest of this stuff.
That's equivalent to just us decrementing on the last version, right?
Uh-huh.
Technically,
Yes.
Yeah. Okay, cool.
Yep. Okay, so I mean, I hope, you know, let's go back and look at the picture and see what happens when we pop, okay? I think that's important enough to warrant a little switching back and forth. So if I now call the pop function, that means I no longer want the 17 to be on the stack. I want the stack to just be 7 at the bottom, 13 on top of the 7. The way I implement that is I simply take list and make it point at list arrow next. Oops. Take list and make it point at list arrow next. Done. Now my stack is 7 at the bottom, 13 on top of the 7. That's it. Clear?
Yes. Are we obligated to deallocate the memory for 17?
Yes. We haven't done that yet, but
Okay.
I wanted to make sure this part was clear so far. So yeah, before we move this, we're going to have to set a temp pointer to point at this one so that we can then delete it, right? So going back to the code. Create a temporary node pointer that points at the first element, the first node in the list. And then after I have moved list to point to what was the second item in the list, delete temp. Okay. Any questions about pop? Okay. I'm going to change this. I'm just going to say assert not is empty. Did I call it is empty? Yes, so. The STL just calls it empty. The textbook calls it is empty. I kind of actually like empty better, but apparently at some time in my past I liked is empty better.
Well, empty gives you the false impression that you're gonna delete everything in the.
So you could
Stack,
treat it as a command, as you know, empty the list, as opposed to checking to see whether it is. See that? I don't know. Yeah. Okay, so then assuming that the list is empty, also is not empty, all I need to do is assert list arrow, not assert, return list arrow data, right? Because that's the list is pointing at the first item in the list. The first item in the list is the top of the stack. And so we're just returning the data from the top of the stack. Any questions about top? Okay. Push. I think this is pretty much what we talked about when we were looking at the picture, right? Create a new node, put the data in, make it that new node's next field point to the node that list is pointing at. And then, oops, this should just be, and then make list point to the new node. Okay. I think I did that a few times while we were looking at the picture. So if this is not totally clear, make sure you go back and take a look at that part of the recording. Is empty is just going to be list equals null pointer. Okay. And then this is just our destructor. Go through the list and delete everything. Go through the linked list and delete all the nodes. Okay. Shall we give it a try? That was a lot of code. It involved linked lists and pointers. So I would not make any bets on this, but let's see what happens. My stack client.cpp includes my stack. Okay. In the client, I called it empty, so I better call it empty in the class. Call it empty there. All right, try again. All right, here we go. Open, open, close, open, open, close, close, close. Oh, thank you for reminding me. So there's my terminal. That's my errors that I fixed. Compiled it again, and I'm about to see if it tells me that that is in fact balanced. Uh-oh, segmentation fault. Okay, well, we made an error somewhere. Give me like 30 seconds to look this over. going to cheat a little bit and just take out some of our memory management stuff and see if that helps. Whoops. Oh, maybe it crashes. Let's try that. There we go. Balanced. Yay. All right. So apparently I have something wrong with. I don't think that's the problem. Let's try that. Whoops. I think I want to try to come up with a more interesting. Balanced. Okay. So the error that we got before had something to do with my destructor. Somebody's list this. Oh, I guess this should be a while.
I think you're going to try to delete a null pointer that way.
Yeah. List,
anyway, I might be wrong.
While list is not equal to null pointer, make temp point at it, move list down to the next thing. So it might be moving it to null pointer, but that's okay. Delete temp. I think this will probably do it.
Yeah, I think that's right. I think.
Sorry, this really isn't all that useful for you guys learning about stacks, but I'll just have to see if I can fix it real quick. Open, close. I don't know why I always put in balanced. I guess I should try unbalanced, but all right, so I think we're good now. Just in case you're curious, the version of the stack that I had in there before was using an alternative technique for dealing with linked lists, which is you have a header node at the front of the linked list that is just a dummy node. It's just sitting there and never has anything in it. And it turns out that when you're dealing with linked lists, taking that approach simplifies some operations on the linked list. But in the case of a stack, it doesn't really. So I'm not sure why I did it that way before. And we probably will not have time to talk about that alternate implementation of a linked list this semester. But if you ever run across it, it shouldn't be that hard to figure out. Okay. Anybody want to ask a question? I realize I kind of went on a little bit there at the end, but that was just to fix my code. I think that's all I have to say if there aren't any questions. Let me talk a little bit about what's coming up. Okay, the next 2 weeks, the subject is the abstract data type list. And basically, I'm going to say more than most other topics, we're going to depart from the text a little bit. We're still studying the same thing that's in the text, but I'm going to have you implement a completely different list than the one that is defined in the textbook chapter. And it's the second half. So it's a 2-week assignment. And the second week of the 2-week assignment, this is not the assignment you're doing now. I'm getting ahead of myself a little bit here. But the 2 weeks after that, the second half of that 2-week assignment is probably the hardest assignment you'll do this semester.
Yes.
So just putting that out there for you. Doing a difficult linked lists assignment is sort of one of the rites of passage of writing a data structures class, right? But on the other hand, I think I've done quite a bit to make it as painless as possible for you. So maybe I'll be wrong and it won't be all that painless. We'll see. But what I wanted to say is there's really not all that much more for me to talk about. So I might, you might find that I cancel 1 or 2 lectures over the next couple of weeks. Just because you already know everything that I have to tell you about linked lists pretty much. And you could probably just use that extra hour and a half to work on debugging your assignment. So anyway, just putting that out there. Anything else you want to talk about before we are done?
Yeah, real quick question. I don't see a final anywhere. Just to clarify.
So we, there is not a final. Technically speaking, just to be following the rules of the college and stuff, we would have to say that like the quiz number 14 is actually the final, even though it's not. I'm blanking on the word. It doesn't cover everything from the whole semester, and it's not worth all that many points. Because technically,
it's not cumulative.
Cumulative, that's the word. Thank you.
Yeah.
Or I could, the last assignment of the semester, I could say that's a take-home final or something. But,
Gotcha. Okay.
Right on. Instead of having an actual exam for the final, I think it's better to spread it out over the quizzes and also focus on the programming assignments. So, all right. If there aren't any other questions?
No, thanks, Dave. Feels good to be back and caught up finally.
Cool. I will see you all on Tuesday.
Later, y'all.
Thanks. Take it easy.
Have a good one all.